Hey everyone, right, I'm back again with another derivation. So it's similar to this one that I just did a few days ago, deriving two formulas of trigonometric identities, trigonometric compound angles. So those ones were for sine A plus B or alpha plus beta and cos alpha plus beta. So this time I'm going to go through the derivation for the other pair, which is sine alpha minus beta and cos alpha minus beta. And it sort of starts the same way. Let's see how it goes. So we start with a rectangle. The rectangle, this time, the angle alpha is measured from this line all the way to this line. Then we still start with labeling the rectangle. Let's call it a P, Q, R, S, and then the line coming from P to a point on RQ we'll call T. The line coming from P to a point on RS we'll call U. So like I said, now UPQ is alpha. It's the angle in red. And then the green angle will be beta. This makes the blue angle the difference between the two. So it's alpha minus beta. Now PT is 1 unit as it is shown here. Then with alpha minus beta here and B here, the whole angle, the red angle is alternate with this one, which makes this one also alpha. Then we see that this plus this is 90 plus alpha. Then for the whole of this to be 180, we need to add 90 minus alpha. So which means this angle here is 90 minus alpha. Then this makes this angle alpha. So now that we have all the important angles, we can now go and try and find the sides. So in this right angle triangle, so this time around the 90 degrees is on SR, not not on RQ or on this vertical side. So the 90-degree angle is over here. So in this right angle triangle, when we want the cosine of beta, we will say it's UP over 1. So it means UP is cos beta. And then if we want the sine of beta, we'll say UT over PT or over 1, which means UT is sine beta. Then coming to this triangle, in triangle PTQ, again, if we want cos of this angle here, it will be PQ over 1, which means PQ is cosine of alpha minus beta. And then if we want the sine of alpha minus beta, it will be TQ over 1, which means TQ is sine alpha minus beta. Okay. Then in triangle RTU, RUT or RTU, this triangle over here, we see that sine of alpha is UR over UT, and UT is already been determined to be sine beta. So we can substitute that UT. So making UR the subject, we multiply both sides by sine beta. We get UR equals to sine alpha sine beta. So let's go and put it over there. Then again, in that same rectangle, triangle RUT, we say cos of alpha is going to be given by RT over UT. Again, UT we know is sine beta. We substitute it in. multiply both sides by sine beta, we get RT equals to cos alpha sine beta. Then we put that in over there as well. Okay, now we go to triangle SUP. In triangle SUP, cosine of alpha is SU over UP, and we know what UP is cos alpha, so we substitute in and then multiply both sides by cos beta. We get SU equals to cos alpha cos beta. Let's put that over there. Then again, in the same triangle SUP, we say sine alpha is SP over UP. UP is known to be cos beta. So we substitute it in, multiply both sides by UP. Then we get SP equals to sine alpha cos beta. Let's put it in. Okay, now what have we achieved? Just like last time, we use the property of rectangles. We say PQRS is a rectangle, so opposite sides are equal. So we see that this side will be equal to that side over there. So this side is cos alpha minus beta, and then it is equals to cos alpha cos beta plus sine alpha sine beta. Then again, we go to the other pair of opposite sides. We have this side here plus this side here. So that is sine alpha minus beta plus cos alpha sine beta. And it is equals to this opposite side here, which is sine alpha cos beta. Now, making this one the subject of the formula, we take this to the other side, and then we end up with sine alpha minus beta equals to sine alpha cos beta minus cos alpha sine beta, which are the two compound angles with a minus. So that is another way of deriving them. Thank you very much. Subscribe for more videos. Share this video, press like, and then I'll see you in the next one.